Yeah,
Awesome.
could you?
How are you doing, Javier? Welcome, everybody. Super glad to be hosting this workshop with Goldsky. Let's maybe start with some quick introduction. What is it that you do, Javier? What is an indexer? Give me the full package.
Okay, sweet, sweet. Oh, actually, that allows me to go into the next one here. Cool. So my name is Javier. I'm originally from Spain, but I'm based off Lisbon in Portugal, and I've been with Goldsky for over 2 years. And yeah, at my role at Goldsky, what I do is I'm a solutions engineer. So it's everything about helping customers integrate and making the best out of our platform, basically. One of those things is indeed these the workshops for kind of the community to understand how they can leverage our products to index data. And so I'm going to be talking about the indexing at a very basic level and in more detail as we go into the workshop. But yeah, basically, indexing is the technology that allows you to understand and make sense of the chain, because everything on chain is fantastic, but at the same time, it's quite cryptic, if you may. It's a little bit difficult to make sense of it. So we basically allow you to make sense of all the data that is on the chain, and in the end, power your dApps or whatever kind of analytics or use case you want to accomplish on the Web3. Yeah, I think that was a good intro. Any
So here are a couple of questions because when I got started into Web3 development, obviously, like kind of the first thing that you learn is about Solidity development and whatnot. You maybe create like this Hello World kind of program, whatever. Then you learn how to, publish data and retrieve data from the blockchain. And then it comes to the question of building, decentralized applications, right? And then at some point, you will need to interact with the blockchain and get data in a smooth, fast way, right? So I can imagine that that's where indexers comes into play, and that's how they were born. So I was wondering, in your experience, what are kind of the most common applications that really, really rely on indexers? I'm asking this because if we have a new Web3 developer, that is just starting with vibe coding, deploying their first contracts, they might not be aware of the kind of applications that would require utilizing this kind of tool.
Yeah, okay, that's a great question, and I'm gonna get into detail into that. But I think, like at this point today, I would say that unless you're doing a quick experimentation or test on your end with your application, and I think you're probably gonna need an indexer for sure for pretty much every application, especially if you look into applications at scale. Many use cases come to mind. Like you could be powering a block explorer, you can be running analytics to understand, to get insights on chain activity. You can be, doing on-chain games or maybe anything related to trading, high frequency trading, for example. Like I would say anything you these days really needs an indexer because you still want to mimic the experience in Web 2. And otherwise your other alternative will be to query the RPC nodes directly, which is actually very inefficient. And I'll be talking about it in a second indeed.
Yeah, okay, yeah, that was kind of one of my questions that I had in the back end of my head because eventually, like, one could think, okay, I could figure out other ways to do this. So it would be great if we can, provide some strong arguments, maybe show some data to demonstrate why really like utilizing an indexer and how easy it is to do it with the interface that is provided by Goldsky. So before we actually dive deeper into the rest of the workshop, why don't you tell us more? I don't know if you have prepared a slide or not about Goldsky, in terms of like what you guys have been doing, maybe some future updates, maybe a little bit about the story behind Goldsky, whatever it is that you have prepared or that comes to your mind, I think would be beneficial in order to have a little bit more of context.
Got it. Okay, cool. I'll just improvise this off the top of my head. But basically, Goldsky is a company that has been around for over 3 years. We are an enterprise grade indexing solution. Originally, how it came to be is basically our founders identified that existing indexing solutions back then did not have the actual development experience that we needed to really make the transition from web to web3 experience. And so we started off basically making SAF Graphs, which was the original indexing technology, a lot better. And you will see how, just basically by really adding features that make the overall developer experience a lot better, but also making the systems more resilient, making the economics of it much more predictable, and also like making things a lot faster to deploy and to index. And then later on, we focus on another kind of like a paradigm shift when it came to into indexing, because we acknowledged that SAF Graphs were not going to really scale for every use case. So we created what we call mirror pipelines. And so basically that's a new way of indexing data where you're not really relying on a GraphQL endpoint anymore, but instead we are actually creating ETL pipelines to stream the data into the database of your choice. So yeah, that's kind of a sneak peek into what we're going to be talking about today. I will be, maybe this takes me into here. I will be covering indexing the basics at the beginning, talking about SAF Graphs, and then all the way down into how we can stream this info using mirror pipelines, basically.
Sounds super interesting. At some point, then during the rest of the workshop, probably I'll be asking you more about mirror data and going beyond indexing. I think this is not a very common topic to discuss among Web3 tooling and whatnot. So super excited to dive deeper into this workshop. So let's go ahead.
Cool. All right, cool. Let's go for that. So basically, let's start with the beginning, right? Like why indexing is important and kind of how it came to be. I kind of touched upon this on the introduction, but basically, blockchains are a great technology. Of course, they give us a ton of great benefits when it comes to decentralization, trustlessness, inclusivity, etc. But when you think about actually making use of the blockchain, writing into the blockchain is relatively easy these days, but reading from the blockchain is actually quite complicated. And this is basically because all those benefits that you get from this technology is because of the fact that everything is encrypted in a very secure way. So if you were to directly try to make sense of the data that is on the blockchain, you're just going to see this garbage of data, which is impossible to work with. And there's also a ton of data in it, right? Like there's different levels or layers of data. You can go all the way up from blocks, starting from blocks, going down to more granular information like transactions, logs, traces, etc. So if you try to actually make sense of it directly by ancillary methods, which is basically what I explained earlier, which is talking to an RPC node directly, it's actually kind of difficult because first of all, things are going to take a long time to be if you're, for example, you're rendering your own website, and this is something that we actually did ourselves here on this test. I don't know if you can see that in this snippet here, but we were trying to render 20 NFTs on this web UI that we created, and it took up to 41 network requests to just display 20 NFTs, which is like arguably something quite simple to do in Web 2, and it should also be quite simple to do in Web 3, right? If you follow the standard method of indexing the data, which is basically, or getting the data, which is basically via the RPC nodes directly, then you have to do a ton of calls, and then you also have to do some decoding on the client side. So that adds a lot of load on the actual nodes, and at the same time, it also adds a lot of load on the client side too. So the overall experience is quite inefficient and quite slow. So that's the kind of the first way of indexing the chain that we saw back in the days. When we realized of the inefficiencies of this system, then the natural solution that came to mind was actually create an indexer, right? And so what an indexer is essentially is just a parallel database where the data that is of interest is actually structure in a way that is easy for you to work with and allows you for efficient data retrieval, basically. So you can think about indexers to be like blockchain scrapers, right? Just like Google scrapes the internet, you can think about an indexer being a scraper for whatever chain and whatever contract it's of interest for your application. And so the very first, or the most kind of de facto technology or most popular technology for indexing these days. It's been the SAF Graphs, right? They've been around for a long time, and I think they're a great technology, of course. The way they work basically is that you will deploy a SAF graph pointing to, let's say, to your contract or to whatever you wanna index on the chain. Then the data will be stored in its own PostgreSQL database layer. And then at the same time, you're gonna get a GraphQL endpoint, which will make it very easy for you to query the data from it. And so it's very nice technology, because as a developer, all you need to kind of worry about is building these subgraphs, pointing to the right contracts, and then you just get the data from that endpoint. So you don't have to maintain your own database or any of that. You just get this readily usable endpoint for you to query. And so subgraphs have been around for a long time, and they were originally developed by the Graph. Now we took the technology and we actually made it better in different aspects, which means that we are fully compatible with the Graph. So if you have an experience with building subgraphs, you can very easily, with one command line, migrate your subgraph onto Goldsky. But as I mentioned earlier in the introduction, we also focused a lot into making the overall developer experience a lot better. And so we added very cool features like instant subgraphs, which is I'm going to talk about in a second. We also added the possibility to send webhooks, so you can get the data of the subgraph off into your own systems. You can use tags. We also added in the backend a lot of optimizations to make the systems more resilient, like a load balancer, and a proxy layer, etc. So you can think about normal subgraphs to be a lot better and a lot more resistant and fun to work with, because there's a lot of focus on the developer experience, of course. And so this is something that I want to quickly show you here on this workshop. Some of you may not have much experience with developing subgraphs, which is completely fine, and which is actually the main point of this feature here, which is called instant subgraph. Here, for those of you who have some experience with developing subgraph, you will acknowledge that if you want to build a subgraph right from the start, then you need to build this scaffolding of documents and this structure of documents that then you need to compile. You need to account for it. There's a few steps until you get to deploy the subgraph into your indexer, right? Which can be a little bit complex, and in some cases you don't really have the time or resources in-house to really learn about it. So we kind of acknowledge this, and we decided to make the hard work for you. And so here with this instant subgraph feature, everything you need to do here is just let us know about the contracts that you're interested in indexing, give us the ABI file, and then we'll do the rest of the work for you. And so let me show you what this looks like here. So in this example here, I'm going to go and deploy an instant subgraph for an ERC20 token on the network. And so what you see here is, for those of you who are not familiar with Goldsky, essentially here, there we go. This is the dashboard. Everything I'm going to be doing in this dashboard, I can also do on the CLI. So on the CLI, we have a CLI command Goldsky, and you can do the same. You can deploy subgraphs and deploy pipelines the same way. But to keep it more visual, I'm just going to go and do it here on the dashboard. And so, yeah, so if you don't have a Goldsky account yet, you can very easily create one. The way to do that essentially is you go to goldsky.com. And then here, if you go to dashboard, you can create an account using any of these two methods. And yeah, you just need an email address. You don't need to put on a credit card or anything like that. You just go into a free trial where you can deploy up to 3 subgraphs and 1 mirror pipeline for free, which is actually pretty good and is definitely enough if you want to follow up on this workshop. Cool. So I'm on my own account here on the dashboard. And so what I'm going to be doing now is I will deploy an instant subgraph that will be tracking events from an ERC20 contract in the network, right? So what I'm going to be doing now, I'm going to go to Flare Scan. Let's actually go here. And so let's look into tokens. We'll just get one top token here. I guess I can get, this one, for example, wrapped Flare. And Cool. And so what we need to do here, right, to deploy this instance SAF graph is just, we need the basics for basically. I'll click on this button here. I'll give it a name. So this is going to be wrapped flare. Cool. A version, you can deploy different versions of the same SAF graph if you want to iterate on the logic of it. In this case, we're going to keep it easy. The contract address, I can get this from the Explorer. The network here, it's going to be Flare. Then the start block, I can choose when we want to start getting this data. And so basically, let's say, for example, I'm just going to get the latest transaction, which happened a minute ago. And so I'm just going to get this block. And let's actually remove one number here, something like this. So we're making it from the past, basically. So we're going to get this block here, which, let's say, this block is from 15 hours ago. Cool. And then we need the ABI, right? And the ABI is definitely needed so that we can basically keep track of the pipe of the actual events emitted. And so here, because it's going to be an ERC20 contract, I can just get an ERC20 API, like this one here online. Okay, cool. And yeah, that's pretty much it. So you can see here, I will start indexing events emitted by this wrapped flare contract only by providing the contract address, specifying the network, and the start block of interest, this one for a few hours ago, and the ABI. So that's everything it takes. Yeah.
I have a quick question here. First of all, how do you go in practice to select the start block, right? Because that's kind of related, obviously, with time. How's like the standard procedure or mental process to go about selecting this? Because I can imagine that the process of just going to the Explorer and starting to pick up, a number for the block could be a little bit of a pain.
Oh yeah, for sure. No, and this is definitely, like, you can choose the start block to be 0, the Genesis block, which is also fine. But in some cases, what will happen is that you may just want to index data of your contract of interest when it got deployed, and so this is most likely what. Yeah, I'm just like doing this as an example here to get more data. If you were to always specify a start block to be 0, and let's say that you deploy your contract today, then it's not efficient because you will have the SAF graph having to go through the entire history of the chain until it gets to your contract creation block and starts getting interesting data for you.
Got it. And
Yeah.
the next question would be about the contract ABI, because what I saw is that since it's correct me if I'm wrong, but since it's an ERC20, you just type there on Google, find the first one that you can get and just type it there. But I guess that normally the way to go about it is you go to the contract on the Explorer and try to grab that information from there. Am I correct?
For sure, absolutely. And in some explorers, you don't really get the contract your ABIs, but maybe here we get it. Let's actually see it. Let's see. Well, actually, this is very complete. So I reckon it's gonna be here. Yeah, you see? Okay, so we can also take this one.
Got it.
It's gonna be the same because in the end, it's a standard to be used. But yeah, like, I reckon this might be even an easier approach to take, where you just get everything from the Explorer.
Yeah, probably.
Yeah, that's a good one. Good call out. And for those of you who are interested, what happens now? Like, basically, what we're gonna be doing now here on the backend side is that we're gonna be looking at the ABI, and we're gonna be tracking every event that is actually specified on the ABI. So, if, for example, you just want to track, let's say, transfer events from this contract, you can just like create your own API where there is only an object containing the transfer definition. But that's just going to be the default mode of working for these instance subgraphs. Yeah, but just want to call that out. Okay, cool. So there we go. Now we deploy the subgraph. This is good. Let's see. I'll just close this here. Okay, cool. So now this takes me into the Subgraph Detail page. I can very quickly walk you through what this is from top to bottom. You see here at the top, we have the status bar. This is basically gonna show us the progress until it gets from the deployed start block all the way up to where the edge currently is. And then we get some nice metrics here, which are very relevant. Why they're relevant? For example, we look into entities here. At Goldsky, entities is very important because from an economic point of view, we don't charge based on the amount of queries that you make on these subgraphs. Instead, we charge per the amount of, we call them entity hours, which is basically how many entities are stored since you deploy the subgraph. So it's important to know your entity count and how many entities are created in the subgraph. Then you're going to get some good metrics around the API request and latency in case you are basically servicing this subgraph to your clients or whatever application you're powering. And then here we realize that sometimes people want to optimize their subgraph code. And so here we provided with metrics around what are those handlers or those parts of the code that are taking longer to finish. Because ultimately, even though they may take a few milliseconds, everything sums up, right? And so if you want to really speed things up here, you're going to have enough observability to realize, hey, if I tweak this thing up here, this is going to take a few milliseconds, but ultimately will translate into maybe a few hours on the bigger picture of the indexing process, basically. Cool. Well, so what I was talking here, you see that the status went to live. So we already indexed everything from the starting block to edge. So now the subgraph is live, which means that it's tracking events at edge. Here I have a public GraphQL link. So if I click on it, I'm basically taken to my to my endpoint for the subgraph. So now I can query the data. Something I personally really like a lot is this folder here icon. If you click on it, it's gonna open up this nice kind of a helper whereby you can basically build your query object by selecting the entity of choice and then how you want to basically do the query based on these params, and then based on the attributes that are available for those entities to be retrieved. So in this example here, I can just say that I want block number and everything about the transfers that have been indexed on this event. And then you can see here, I got the info over here, right? So of course, like ultimately, this is gonna translate into what's available on the let's actually go back on this view, on this transfers view. So you could ultimately, for example, power a block explorer like this one using Subgraph on the backend and just basically having this information being displayed nicely on the UI, like here. Cool. So that's one thing here. Sometimes, it happens that you may want to kind of build in private, or you're dealing with any sort of sensitive information. Then in that case, you can very easily open up and create a private GraphQL link. So in this case here, you get another GraphQL link, but the difference is that you need to have an API token on your requests to be able to access the information. So you see here, if I try to basically talk to this endpoint without any API on it, then it's just not going to work. So this is good for those applications that want to be in private or want to deal with sensitive information, basically. You see here that as I was doing requests on the API, you see the request, the API request metrics goes up, as well as the latency, just to give me that observability. Now see here, in terms of observability as well, there's a bunch of data that you can look into here. We give you different types of logs based on their level of importance or kind of a scope. In some cases, you may want to deploy a subgraph and put your own logs. And then here you get full visibility into the execution of the subgraph. This is like very relevant on the development cycle as you go and deploy newer versions of the subgraph based on any change of logic that you may have. Also, sometimes, as you go and deploy new versions of your subgraph, there is this issue that we also saw that happened a lot, which is like basically people will connect their applications client applications or backend front-end apps to the GraphQL endpoint that is provided, like over here, which is this one. This endpoint consists of the name of the SAF graph and the version, which means that every time that you deploy a new version, the endpoint is going to change, right? And that could be quite inconvenient for those applications that are connected to this GraphQL endpoint. So
Yeah, I was thinking about that. So I have like some questions, like very basic, because from the workflow that you have just showed it, okay, essentially we go, we check out the contract, and then we can start getting data from the blockchain utilizing this tool, right? But then most likely I will want to do something with this data, right? Fetch it or trigger some action on a contract. So how does that part work, like at super high level?
right, yeah. So basically, this is, this GraphQL endpoint that you see here, when I go into this page, by default, it's going to give you this nice UI, which will allow you to build these query objects and just like play around with the info and, see that the data is good, that the healthiness is good, the SAF graph. But in reality, this is going to be powering your dApp on the back end. So the way you're going to be really coordinating and talking with this endpoint is going to be more on a programmatic way. And so in reality, this thing here, so for example, I don't know the implementation of this Explorer, but it is possible that this thing on the back end is actually getting the data from a subgraph, basically. Just like if you look into the data that's displayed here, it's basically the same one that we get here. And so that's the way you will be getting the data most of the time.
Yeah, makes sense.
Yeah. And so in that regard, what happens is that, it's very common that you deploy a subgraph and then you want to change the logic in it as your application and your needs change. If you have 1,000 applications reading from an endpoint, and then you change the endpoint to a new version because of a fix or a new feature, it's going to be super inconvenient for you to to pretty much update that endpoint on every single app. That's like, it doesn't work very well, and it's going to take a very long time to update the overall systems. So this is something we acknowledged back then, and that's why we created these things called tags, right? So what you can do here is that you can create a tag. For example, let's call it production. And so what this tag is going to do is it's going to give you a fixed endpoint here. So you see here it's going to be rat flare production. And so what happens now is that this thing under the hood is basically redirecting the query to this subgraph on this version over here. What you can do now is that you can deploy new versions of your subgraph, and then you can move the tag across those new versions, so that in reality, from the client point of view, the actual endpoint is going to be the same, but the underlying subgraph is going to change. And this way, you can iterate on new code without having to change the external systems, basically. Cool. So that was a feature I wanted to kind of talk about. Another thing that is actually quite cool here is that you can get this data off to your own external systems as well. So that would be via webhooks that get pushed into an URL that you specify. And so the way it works is that basically you can create webhooks for every entity that your subgraph creates. And so this way, anytime that there's an addition or removal or a new entity created, you're going to get a payload, which is very similar to what you see over here, pushed into an external system of yours. So that's more of a proactive way of getting the data into your own system, rather than having to pull the data from the endpoint, like here. All right, cool. So that's pretty much it. There's a bunch of optimizations done on the backend side to really ensure that the subgraphs keep up and running. And one of them will be, for example, when we index a new chain, we always try to make sure that we have not only one RPC node, but we have a bunch of them, so that if anything happens with one node, we can very easily reroute the request to the most efficient node. So that way, your subgraphs are always pretty much up and running. Okay, cool. Now coming back to the demo over here, subgraphs are pretty great, as you can see, because they're great in terms of the developer experience. and they provide you with this super convenient endpoint that you can use to query data. You don't have to worry about basically maintaining the data layer. That's going to be done by the indexer for yourself. Now, the thing is that while those are great advantages for some use cases, and as you go into more scale use cases, the Subgraph technology is going to start falling off. And so why that happens is in big part due to the fact that the only way for you to query that information from the Subgraph is going to be via that GraphQL endpoint that I was showing earlier. And so the thing is that in some cases, your application may need to power very complex scenarios, like, for example, scenarios where we not only change with on-chain data, we also need to deal with off-chain data or maybe with cross-chain data. In some cases, you may want to power more applications that need faster speed, right? So, for example, some sort of a fuzzy search, so that as you type, you get the results or a preview of the results immediately. Maybe you want to have big analytics going on a real-time analytics database. All of that, if you try to power those applications through that endpoint, GraphQL endpoint, is going to be pretty much impossible to do with low latency and with through output. At the same time, there's also some other, let's say, cutbacks or some other shortcomings when it comes to dealing with subgraphs. One of them is subgraphs can only deal with on-chain data. If you want to bring off-chain information into the subgraph, then you will need an oracle, and then the oracle will put the data on-chain, right? And so it's more complex, and it doesn't really have to do much with the data layer. That will have to be done on the contract layer. There is also the problem that subgraphs as well, they index the data sequentially. And so what we're seeing these days is that we're getting chains with faster and faster speed, right? The block time is going to be faster and faster. And you for example of it will be, for example, Mega ETH, or another one would be something like Somnia, right? The block production time is way faster than what we used to see a few years ago. And so subgraphs will be indexing these blocks sequentially, which means that if your subgraph is a little bit heavy in terms of the compute that it needs to calculate whatever you're indexing, it's very, very likely that it's not going to be able to catch up with Edge all the time. So you're going to be start to falling behind on the, compared to the chain of the chain. And so what that means is that if you're powering a very low latency application, like some sort of, for example, gaming, or something like DeFi, or maybe some sort of, for example, a chart where you can just buy and sell, and the chain is too fast, then you're just gonna be displaying historical and old information, which is not good enough. Cool. So, we saw these shortcomings and we wanted to find a solution for it. So what did we do? We basically created a Mirror to solve this problem. And so with Mirror, you can think about it as being a kind of a paradigm shift when it comes to indexing. Here, we are not providing you with the data via this GraphQL endpoint. Instead, we are actually pre-ingesting the data, and we allow you to create ETL pipelines that allow you to stream the data real time into whatever database of choice you want. So, depending on your use case, if you, for example, want real-time analytics, then you can send the data into something like ClickHouse. If you want to put the data into something more of a transactional database, you can put it into Postgres. If you're looking into, doing fuzzy search, for example, as I mentioned earlier, you can put that into Elasticsearch. So, now you have full control of the data, and also you can mix and match the actual data. So you can change the shape of the data. You can enrich the data with offline data sources. You can pretty much control the full life cycle of the data. So that's Mirror here.
So I'm not sure I'm fully understanding this. Maybe we could try to simplify it, because you mentioned that we had an alternative instead of having GraphQL, right? So can you elaborate a little bit further on what are the principles, or maybe put it in a more basic way for people that are not that data savvy?
Oh, yeah, for sure. Yeah. So what you saw earlier with the subgraph, right, is that I created a subgraph and I started indexing the events for that token, right? For that wrapped token, and then we we had the data available via that endpoint that I was mentioning earlier, right? Which is this GraphQL endpoint here, right? So
Yes.
now I'm able to make sense of the data and work with the data using this endpoint, and I can connect my client applications to this endpoint here, so I can basically power my dApp this way. So this is good, but then in some cases, this is not that great. Like in some cases, the way the data is given here is not very convenient because maybe, I don't know, maybe I'm not supposed to be working with a graphical endpoint. Maybe I just want this data to be on a database of my data warehouse, so I can mix it with other data stores that I have. So for example, you may have data about your users or data about other parts of the system. So you would want to have this data into your own database, so you're able to actually work with the data from a more database perspective rather than from an application perspective. At the same time, if you have the data on your DB, it means that you can also optimize your own database to have queries performed at a much faster speed, and also allow you to deal with much bigger loads of data than just like what this endpoint is able to give you, because this endpoint at some point is not able to keep up with a maximum amount of requests, for example.
Got it.
So what you do here now is that instead of having the indexer give you the data on demand based on this endpoint here, instead we're gonna take the data, we're gonna stream the data in real time into a database of choice based on the application that I want to power, basically, which is something I can show you in a second.
Yeah, let's see. So it's essentially instead of having this endpoint, we're going to be streaming this to another database.
Yeah, exactly. To a database of your choice. Like
Yeah.
if you work with an indexer, you're pretty much constrained for about the possibilities that it gives you in terms of how it services your request to give you the data, which is limitations on how the data is served in this format, but also the capacity that it has to give you the data. Like for example, it may be that your indexer is located in another part of the world, which is a bit far from you, and then there is some added latency in there. So that's also relevant if you're powering low latency applications, for example. So pretty much the data sits with the indexer instead of sitting where you want it to be, basically.
Got it. Understood. Thanks.
For sure, yeah. So how do we create these pipelines, right? Or these mirror pipelines? I'll show you a pretty quick example here. So it's actually quite simple to do. You go here into pipelines and create a new pipeline. Now here you are presented with this canvas, and so when you create a mirror pipeline, at the bare minimum, you're gonna need a data source and a sink. A sink is basically a destination database. Now, optionally, you can also add transformations in between, so in case you want to transform the data so that when it gets real time in your end, it has changed somehow based on your needs, right? That could be, for example, by removing some parts of the original data sets that you're not interested into. Cool. So let me give you an example here. So what I'm going to be doing now, I'm going to stream some data from Flare Network into a database of choice, and I'll choose a database later. So first here, you see, if I go to Flare here, what we can do is that we can power, or we can take data from either data sets or subgraphs. Now, subgraphs will be subgraphs previously deployed on my account. So this is the one that I deployed earlier. Data sets are basically raw data that we pre-ingest on the network and is readily available for you. So you get different levels of granularity, and depending on your application, you may want to do blocks, you may want to do logs or transactions, and we can even ingest other pieces of data based on what the network requires. In this case here, we have blocks, logs, and transactions. So let's say, for example, that my application needs logs. So what I can do, I can choose logs here, and I can take a look into the actual data that is going to be flowing into my DB. So this is all the logs on the network here. And this is the shape of the data. That's the schema. One thing that I can do here, I can add some filters. So I can, instead of getting all the logs of the network, I can just decide to get the data either from the beginning of the chain or from the tip of the chain, in case I'm not interested in historical data. I can also filter the data by a specific contract address, or maybe by some sort of topics, right? Which is basically the actual events that get populated. We can just we don't really need to do any of that for this simple example here. What I will do just for the purpose of demonstration is add a simple transform here, so you can see it. A transform can be, and as I mentioned before, a transform allows you to basically change the original data source, which is the raw logs in this case. There's two ways to transform the data. You can either use SQL so that the transformation happens within the environment of the pipeline, or you can do HTTP handlers, which is basically here where you define an endpoint and we send, the pipeline sends in real time the information to an endpoint that you host, and that endpoint will do the processing. So, for example, you can have a Lambda where it will get the logs and it will do some calculation and it will add a new result back into the pipeline. That's also possible. In this example here, I will just select a custom SQL. You see here that I have a SQL editor, and just for the purpose of this, what I'll be doing here is I will take, instead of getting the original data, I'm just going to be filtering the data attributes, so that ultimately I'm just going to be getting the ID, let's say the block number, and what else? And maybe the, for example, the address. Actually, well, of course, on the topics. Yeah. So now here, instead of getting all this information streaming to my end, I'm just going to create a subset of this data, which is going to be this one here. It's just a very simple way of, of actually transferring the data. Now, last point here is I can sync the data into my database. We support a number of different databases here. In order for us to be able to sync data into your DB, you first need to create a sync, configure it, basically. I have a bunch of them created here. I can show you a quick example of how this will look like. So basically, here you will go to sync type, create a sync type, and you see that we support a number of different technologies. So depending on your use case, we will be syncing the data into a different database or even a webhook as well. You can also sync the data into an endpoint in your end.
Here I would need a little bit more of maybe context, because how am I supposed to know how to, which of all of these to select? What is some recommendation or typical use cases or something that you can share in terms of, different use cases, different choices for each case and whatnot?
Yeah, for sure. I think so for example, right? Well, I think one thing worth mentioning is that sometimes by the time you start using pipelines, you already have your application stack developed. And for instance, you may have most of your off-chain data or some of, even on-chain data in a more relational database. Something that I personally see a lot is people using Postgres. I think Postgres is quite a very good transactional database I use a lot these days, or MySQL as well. So sometimes you just want to keep the existing database technology that you want because you are confident with that infrastructure and you like to work with that type of database. In some of the cases, you may be looking into, okay, I need to sync the data into this specific database because I know that it's going to be a lot more convenient, or a lot more efficient for this use case. In that case here, you can look into what I mentioned before, for example, ClickHouse is a very, very good database for real-time analytics. In fact, if you look for, I reckon if you look for ClickHouse on their website, they will probably mention something like that. Yeah, so it's more of an all-app, pretty good for real-time open source database. If you're looking into, for example, fuzzy search, you will do something like Elastic. If you just want to put the data into an intermediate database, something like S3, SQS, that's also possible. Or if you just want to enrich an endpoint that you have on your end, you can also send the info onto a webhook directly. So in this case here, what I see in these cases is that the people, instead of having the data persisting on a data layer, they just basically present the data directly to the user as it comes. So the data is sent to the webhook, and from the webhook directly to the front end. So there is no intermediate data layer. There's no persistence of the data. The data is just shown as it is. So, it depends on what you're actually looking for and what your data needs are. There's always going to be a best technology to work with, basically.
Got it. Thanks.
Yeah. One thing that I'm personally very excited about is this thing here that we released relatively recently, which is basically hosted Postgres. So what we do here is that instead of you having to have your own database, we provide you with your database. So in this case, Goldsky is gonna set up a DB for you, and then we will give you credentials so you can access the DB and you can just basically own the DB without having to maintain it. So I'll show you an example of what this looks like here. So I'm just going to create a new DB. I'm going to call this hosted Claire, for example. And now you see now the database is going to get provisioned as we speak. All right, cool. And now here I can access this DB via pSQL. So if I go here, cool. If I pSQL into it, and pSQL is just a way to access the DB from the CLI, I can see here that I just have this DB ready for me to use, which is completely empty. There is no relationships in it. What we're going to be doing here is we're going to be syncing the data into this DB, and you'll see how the pipeline creates a new table for it and starts streaming the data on it. Cool. So we have our pipeline, which is very simple. We're going to get all the raw logs from the beginning of the chain. We're gonna, get a subset of the original data source or the data schema, and we're gonna sync the data into this new hosted DB by Goldsky. And I'm gonna call the table. Let's actually call it logs, for example. All right. So now, ultimately, a name for the pipeline. So the pipeline, I'm just gonna call it Flare logs, for instance. Cool. And then the last thing here is when I deploy the pipeline, I can choose the resource size. And so this is very nice because basically the resource size is the amount of compute that you are going to add to these pipelines. And so when you go for a small, you're going to get one worker, and pretty good. It's going to be pretty good size, but it's just going to be one worker. If you want to look into backfill a ton of data, and when I say backfill, backfill means getting historical data and put that into your own DB. Sometimes if the DB has a lot of history in it, there's going to be a lot of information, a lot of data to process, right? So in those cases, you may want to add more compute to it. So you can go all the way from small to XX large. And so the higher you go, the more workers you have, so the more parallelism there is, and the faster it will start syncing data on your end. And so for this example here, I'm just going to go for small, which is really good enough. Cool. So we go ahead and deploy this. And now basically on the back end, what's happening here is that, we are setting up the right resources for the pipeline to start streaming this info onto our new database. Now here, what you see is that we have kind of a page which is very similar to the Subgraph Details page from before. We also have metrics. These metrics will give you some visibility into the records that are read by the pipeline, in this case, the logs from the chain, and the ones that ultimately get written onto my sink. Now, what you see here, we're also going to have some logs, which we're going to be looking at in a second. Something that is kind of relevant to call out is that we have here the pipeline definition. And so this definition, which is in the YAML format, is how pipelines are actually defined formally. And when we work with the UI really kind of encapsulates the complexity of working with these files. But in reality, this is how you will define formally a pipeline. So if you're working with the CLI instead of the UI, you can create pipelines this way and then deploy them using the CLI. So why would you do that? Because this gives you a ton more flexibility. Like once you become more capable, more comfortable working with pipelines, you'll probably want to switch to this, because here you can have your own definitions in your own GitHub repos. You can write code into here, and then you can even deploy these pipelines programmatically using something like CI/CD processes, for example. So you see here, here's the sources section, one source from raw logs, our transforms, and the sinks. It's actually quite simple, I would say. Okay, cool. Now, if we look into the logs here, the pipeline has started. The table has been created on our end. And if we go up here, we see that we got a lot of records received and a lot of records have been written. So if I now go back here and I do DT again, we can see that the logs table has been created. So now I can select a few of these logs. So let's actually link this to 10 records, for example. And then we see that all the logs from the chain has been added here, and that we're getting a subset of the original data sets. We're just getting the attributes that we really wanted to get from that pipeline, basically. Cool. So then that's pretty much it. As you can see here, you're going to start to get a lot of data here very fast. And now it's really up to you what you want to do with the data, right? You can run complex analytics from the database directly. You can pull an API on top of it for other people to use it. And now you kind of own the data, and now you can do whatever you like with it, basically, which is actually very, very powerful, I would say. Yeah, that's pretty much it for me. Pretty much the end of the demo. Hopefully that was insightful, I would say.
Thank you. Yeah, thank you, Javier. I think this was very helpful for people that are just getting started. In my opinion, maybe something that would be good to highlight at this point are maybe two things. One, about resources that people can check out and keep learning. I think that in the future, probably you and I are going to do something else, right? In which maybe we power a decentralized application using the indexer from Goldsky, like in a real scenario. I think that would help. But other than that, I think that people need to go and check out probably the documentation, right? So that's one, like finding good resources to learn more about these kind of things. And the second one is about, how to save. Because you guys, if I understood correctly, have a sort of different pricing model compared to other indexers. So of course, developers, they want to save and want to be efficient with their resources. So maybe a tip or two on that note would be helpful.
For sure, yeah. So I guess like the first one here is definitely, I guess like I'll share with you this presentation because there is some links on it at the end. There's some references so people can go and check it out. And it's going to go into more detail about the things that we talked about today. But definitely, I would recommend take a look at the docs. We put out some thought into how these docs are constructed. So there is videos on it. There's a lot of tutorials. So even the non-expert person can go all the way from knowing nothing about Goldsky to being indexing tons of data according to their needs. That's one thing here. At the same time, we're also pretty good at supporting people. So, you can always reach out to us via email or via Telegram, and then we can help you in a more, one-on-one basis to implement the applications you're powering. That will be one thing, actually, for sure. Now to the second point here on pricing, I'm not really the pricing guy, but I can give you a hint into how pricing works. Basically, most of the indexers will charge based on queries rather than, based on queries, basically. So you will deploy your SAF graph, and then based on the amount of queries you make, then they're gonna charge you whatever dollars. In our case, like queries are for free, right? You can query as much as you want. Now, from our point of view, the actually like billing factor is going to be on the Subgraph side is going to be how many Subgraphs you deploy. There's going to be a fixed cost per Subgraph deploy, and then also how many entities these Subgraphs are stored. So you're gonna get a component called entities hours written. So these entity hours is what you really want to count against your bill at the end of the month. That's one thing here. Now, on the pipeline and mirror side, how this is being built is there's going to be, again, a cost per pipeline, and then there's going to be a cost per events that are written into your database. So what that means is that you can be very clever at how you deploy the SAF Graphs, and then because something that I showed earlier is that you can add filters onto the pipeline, right? So you can restrict the scope of writes of the pipeline to only write data that you're interested in. So this way you actually pay really for the data that you need and not for the rest, basically. So that's one component, and then also there's going to be the more resources you put into the pipeline, the bigger the pipeline becomes, the more compute it needs, and then the more it costs, basically. But in most cases, unless you're dealing with huge backfills, an S pipeline, which is the minimum resource size, is already good enough. Yeah, so that's one thing. And one thing that I was trying to check here on the back end is, this is it. Here, I'll send this to you, by the way, right now. Here on this private, is it private chat? Yeah.
Yes.
Cool. Basically, with Flare, we have, Flare is also subsidizing the cost of the ecosystem. For what I can see on this page here, it looks like SAF Graphs are completely free, so that's also paid by Flare. There's also a discount, a 10% discount on Mirror, which is this applied to all the ecosystem developers, basically. So I think that's a pretty good deal, I would say.
Absolutely. We want to take care of our developers for sure. So you're sharing the alpha here. Thank you so much, Javier. Thanks also for taking the time and for all of your effort. It was, I would say, pretty clear and a very nice introduction. And I'm pretty sure that we're going to be repeating this in the future. Today we had this first episode of the Flare tool sort of toolkit tour that we're doing. We're going to bring other partners, but of course, we're going to keep diving deeper because the idea is to generate all of the possible content that a developer that wants to go from zero to hero can get on Flare in terms of like the tooling as well as managing like the basics, right, of the smart contract development and whatnot. So
Sounds
thanks.
good. Yeah, for sure. Yeah, thank you. I'm happy to continue helping you guys in any way, in any shape, for sure.
Awesome. Guys, make sure to connect with Goldsky. Make sure to follow Flare.Hub. Follow me if you want as well. I'm always trying to share some insightful content for developers and users as well. And let's catch up soon, okay? Thank you.